Quadratic systems. This is hearkening back to when we did systems before. But when we did systems a long time ago, what types of equations were we dealing with? So we were dealing with linear equations before. Now we're going to have quadratic equations. And what does it mean to solve a system of equations? Solving a system of equations means finding out where the graphs would intersect. So, we just have to remember how to find intersection points in the calculator. Come in here, go into y equals. y1 is x squared minus 2x plus 1. y2, x minus 3. With magic. Now, up here, we have these two. You want to push zoom, and you want to do option 6 for zoom standard. We have this. So looking at this graph, what is our solution? Our answer is no solution because those graphs never intersect. When you look at those graphs, they just do not ever intersect. So it is no solution. So, in y equals, we've got x squared plus 3x plus 9, negative 3x plus 4. If we graph that in the standard zoom window, you can see one intersection here, but we can't see what's going on up here, so we go to window, change the y max, let's make it 30, graph it. So now we can see there are going to be two zeros. I'm going to punch you in the face. In the face.
That would hurt.
That's the idea.
Every time I change my wife.
Now, Privatera. So to calculate the intersection, they were very, very clever at TI. And to calculate an intersection, you go to the calculate list and you go to intersect. And then you push enter 3 times. One of our intersections is -1, 7. You do second, calculate, intersect. Enter, enter, enter. Now, to find the other one, because we can see there the intersection point they gave us was right here, we need to find this one. Second, calculate, intersect. This time you push enter 2 times. First curve, second curve. The third time, when it's asking us to guess, you need to move your cursor up to where that intersection is, right there, and then push enter for a third time, and it tells us that that intersection point is -5, 19. Now our system is made up of 2 quadratic equations. We're going to add another fun little video box. Same process though. Y equals x squared plus 9x plus 7, negative x squared plus 3x plus 7. I'm going to try the standard zoom window, zoom 6. When you do that, you can tell that our window needs to be extended in what direction. Down. So you go to window, y minimum, change it to -20. Now we can see it. Second, calculate, intersection, enter, enter, enter. We get 0, 7 as one of them. Second, calculate, intersection, enter, enter. Move the cursor until it is near the other intersection point. Then push enter a third time. We get -3, -11. We have to remember that the solution of a system of inequalities is the graph. The last few problems, the answers are points. The answer here is not a point, so we can't just use the calculator to find the answer. The calculator can be a guide, but we have to know how to graph these. So let's start with this one. What is the vertex for this blue parabola? If we use negative b over 2a there, we get negative 5 halves as the x value. What is the y value? We're going to add another fun video box. You guys need to know how to use the calculator. Go into y equals. Put both of these in. We've got, now it's recording, x squared plus 5x minus 8 negative x squared plus 3x plus 4. Those are our two equations. Go to table set, second window. Just make sure that your independent variable is set to ask. Then go to table. It's only going to give us x values we ask for negative 5 halves. It gives us two y values. Why does it give us two y values? Because we put in two equations in y equals. We put in a y1, we put in a y2. Which one are we concerned with? y1, because that's the one we're dealing with right now. So if we plug in negative 5 halves, we get out negative 14.25. So we found that the y part is negative 14.25. On my graph, the y-axis, each block is going to be 2. X-axis, each block is going to be 1. So my vertex for this first quadratic is at negative 2.5, negative 14.25, which is going to be right about there. How do I finish graphing this particular parabola? I will tell you that we can find the y-intercept easily. The y-intercept of any parabola in standard form is the c value. 0, negative 8. Right there. Because my axis of symmetry runs through my vertex like this, I know then that this is a point because of the symmetry of a parabola that we've been talking about. So now I just need another point. How do I get another point? We want to add one more point, so our table is only going to be one row. And let's plug in 1. What do we get if we plug in 1? So our point is 1, negative 2.
Can you plug in the calculator?
Right there. Because of the symmetries of a parabola, if that is a point, then we know this is a point, and now we can graph our parabola. I graph it solid because in the inequality it is or equal to. So now we are going to move on to the second parabola. There. What is the vertex? X part is 3 halves, and using probably the table in the calculator, we get that the y part is 6.25. So make sure you can use the calculator appropriately to get 6.25. So our vertex is going to be right about there. What is the y-intercept in this one? X is always 0 at a y-intercept. What's the y value? The y-intercept, if the equation is in standard form, the y-intercept is c. 0, 4. So right there, meaning by the symmetries, because we have our axis of symmetry for this parabola, again, the vertical line through the vertex, right there. So because of the symmetries, we get those two red points. We need another point. What is another point? If we plug in 4, we get out 0. So that's here. And that is here. So then this parabola is going to look something like that. Where is the shaded region supposed to be?